Hello and welcome to Velofit podcast. As you can hear, we will do this podcast in English, and this is not what I'm very used to, but we will try to do the best. Hopefully, my guest today would be a bit more sharp than me. So I'm very happy to welcome Oliver Kiesel from Germany, who will do a short introduction in a few seconds. What we will do today is we will run through a lot of deep stuff about tires, a bit in general, but then we will move into gravel tires especially. And we will. The reason why we brought Oliver in is because he's a specialist in specialized tires, and recently introduced basically like a completely new tire setup, which I have been fortunate to test the last 2 weeks almost. But it would be like super interesting to go a bit deeper into what is new, what is the ideas behind it. So we have like a pretty long and solid agenda. But before we go into the questions, I would say first of all, Oliver, welcome to the podcast.
Yeah, hello. Thanks for having me today.
Yeah, can you say a bit about yourself? Where are you located and what do you do for living?
Yes, I'm Oliver. I'm German. I live in Germany. I work in Germany, and I work for Specialized. And I work for Specialized in the dedicated tire department. This department is interestingly based in Germany. So the headquarter for tire development of Specialized tires is in Germany. We have a dedicated team here with experts in this field. I work as a product manager since more than 9 years now already in this team. And besides me, there are 8 other people. They are all tire experts working in this department here. We are of course also a couple of German colleagues here, but also very couple people from other countries like Portugal or Turkey or Spain. So we are a very international team here in Germany. All the people have mostly background in tires, have worked in tire laboratories on the automotive side or on the industrialization or in the production or in the quality department. So this is crucial to design tires, that you have the know-how. You find know-how in tires, especially also in Germany, because all the big brands have production or tire development offices in Germany. And I'm speaking here not about bicycle tires. I'm speaking about the greater tire industry, mostly automotive based, because there is where all the development in terms of ingredients for really good rubber recipes happens. Germany has also a lot of automotive industry, and especially Germany and also Europe. There's a lot of strict legislation for CO2 consumption, for example, for cars. So there is a lot of development required to achieve the targets in terms of legislation, as well as performance targets as well, because here are also the best and fastest cars are made. So there's know-how, as I said, as well as ingredient makers, where we source small pieces of ingredients for rubber recipes, what we can then incorporate in the compound and see if it makes the compound maybe more robust, more grippy, or faster rolling. There is also a German Institute for Rubber Technology. This is, I think, one of only 3 global technologies who really have deep knowledge in analyzing rubber compounds for each kind of properties. We have also partnership and projects with them. So there are very good reasons why we are at this location.
Cool. What is your background? How did you come into all this tire and rubber thing?
Yeah, that's interesting. So I'm technically I'm a learned bicycle mechanic.
Yeah.
And have worked in a workshop 20 years ago, and then I did some other economic studies besides that job, and then I stepped into the wheel brand Lightweight, the German Lightweight brand, and have there worked as in the service as well as a product manager. I did this job 6 years. And then I stepped into specialized tires.
Okay. Do you ride a bicycle?
As much as possible, yes.
Okay. Road or gravel or mountain bike?
I ride all of these, but mostly I'm into road and gravel. It is the best here in this region, as also it has the most overlap with my targets for work. And the product I'm working on, because I'm concentrating in particular on the road and on the gravel tires for specialized in terms of the development, the program structure, as well as also the pro team support for these both disciplines. And so, yeah, I'm living relatively close to the office here, so usually if the weather is not too bad, I usually commute by bike, incorporate into it some tire testing or other material testing. Yeah, it's kind of fun.
Cool. Where's the office located?
It is in the northern part of Germany. It is between Hanover and Rhine-Ruhr area, so on the A2 highway.
Yeah.
Is relatively centered, but not very much in the south, for example. So
okay.
It's in the upper part of.
When I was at
country.
It's Specialized, this is 15 years ago almost. It was in Munich or close to Munich. It was at the south where the Specialized office were located. I remember. Also very nice riding facilities.
Yeah, this office is still existing.
Okay.
This is where they do the sales
SPCU.
and marketing activities and all the events administration for the German-speaking markets. This office is still existing. Our office is honestly really just dedicated for tire development.
Yeah. And this is mainly why I also are happy to bring you into this podcast, because now we will shift gear a bit and we will talk about the tires. But before we go into the specific talks about the new gravel tire selection, can you tell me just basic, how is a tire build up? Because now you mentioned compound, different rubber existing. We also have different, words about a tire. But can you explain how is a tire basically built up?
Yes. Before I step into that, just maybe one more comment before to our location. You cannot you can do it, but you're also very limited. Just develop tires on your desk, on paper, on your computer, and then go to a supplier and get your tires somewhere in Asia. You can do that, and that also works. There are some brands they do it also pretty well. We treat it differently, so we really step into our own development of compounds, own development of materials, as I said, and for that reason, you also need the people for sure with the knowledge, as well as also tooling. So in the last couple of years, we have also invested into our location here, into our office, and has invested in a proper workshop for tire development in terms of mixing the compound in a laboratory scale, very precise and with high quality. That also allows us to relatively quickly try new materials from any kind of supplier for different kind of purposes, like better rolling resistance or better wet grip, for example. So we can do this honestly within days, mix a kind of a compound and analyze it in a proper laboratory for its kind of properties. For example, what I said, rolling resistance, wet grip, adhesion, as well as what comes with this all is also not just performance properties, but also manufacturing properties for the process, that the tire is not too viscose, that the tire has a kind of an adhesion to stick on the casing, also the curing time, for example. So we have all this tooling here to develop and analyze it properly, as well as we are able to here to build complete tires. So we cannot just mix the compound, we can also cut casing, we can build a full tire, we can cure a full tire, and we can ride a full tire here.
So you can do everything from idea to actually finished product.
Yes, and this on very on laboratory scale. It is very R&D and focused, not mass production focused, R&D focused. That makes us faster, more precise. And then when we go to a mass production vendor, we can tell them exactly what we want. These are the specs. This is the tooling. This is the thread. This is how we want it, and it will work. It will be very quick, very precise, and we don't provide and open too much secrets to the supplier, because also all the suppliers are also competitors. But we can build full tires and we can also test full tires. So we have our own machine for rolling resistance, for example. We have our machine for endurance testing, as well as, for example, what became really important in the last years is blow-off testing from the rim. So you inflate a tire with water in a reservoir and then test it at what tire pressure the tire blows from a rim. This became very important of all these hookless rim developments.
Exactly, for example. Yeah. There's been a lot of talk about that.
Yes,
we saw it in Roubaix last year.
Yeah, there's a lot to the rim as well as to the tire. Maybe there's more to the rim than to the tire in some cases. But of course, we have to test for these scenarios for product safety.
So
yeah, this is basically how is our setup. So it's not just designing tires. So we are really into the development and into the making.
I think that's quite cool and very impressive that you have. And again, I would say it's typical specialized, because I remember back in the days where, for example, the helmet team in Morgan Hill also consists of like 6 to 8 people, just really specialists, like looking into this. So it was not a far away from like having the idea to actually building a prototype, testing it back and forward a couple of times, and then went into production, where another branch were maybe like 200 people looking into a helmet, and the bureaucracy and all the processing was just like taking months and months. So I really think like having a team as yours and having all the facilities around you is making the process so much easier and much more precise, as you said. Anyway, you were throwing some terms. You were talking about casing and thread and stuff like that, and also like a compound. So before we go into a bit deeper talk about the specific tires, can you tell us a little bit about like how is a tire build up basically?
Yes. So the base material where you make the carcass from, the casing basically, is usually nylon. You get different kinds of quality from nylon. There's nylon 6 and nylon 6/6. Nylon 6/6 is the fabric what is mostly used for higher end tires. So it has better properties for rolling resistance.
Is it more flexible or what is it?
It's just a higher grade of nylon.
Okay.
It's also more expensive, but it's the higher grade you can get, and you get better properties out of the tire. It's more expensive. You have better rolling resistance. Cut resistance, for example, is very similar. Yeah, but for high performance tires, either if it's for a gravity tire, for a cross country tire, gravel or mountain bike, the rolling resistance is very important. This is the highest grade, and this nylon is impregnated with rubber. It's impregnated with rubber. It is a huge machine to impregnate this casing fabric with rubber, and this is basically the base material then to make the carcass. And a tire has a lot of different parts where it is made from. Then you have also the bead, basically the bead to hold the tire into the rim. This could be wire or aramid or carbon or Cylon, depending basically on your application for what you needed. Wire bead is typically, of course, kids tires and active tires, but also for performance downhill mountain bike tires, for example. But the most common material in sport tires is Kevlar aramid. It is
and that's what made them foldable.
Yeah, this is why you can fold them, and the wire tire you can't fold because the wire is stiff, and the folding bead is flexible and is lighter.
Okay.
I
have one question regarding the nylon. There's a saying on the package normally, if it's 60 TPI or 120 TPI, and back in the old days where the tubular was a bigger thing, there was a 320 TPI, and what's as far as I know is threads per inch. Is it the weave of the nylon, or did I get it wrong?
Kind of. So it is how many fiber count you have per inch. That's actually true. But to achieve this, you have also a variable in the fiber itself. As lower the count is, or as lower the number is, as thicker is your fiber.
Yeah.
As thicker is your fiber, and then you basically have them next to each other to fill up 1 inch. And for example, a 60 TPI casing has 420 denier, for example. It defines the thickness of the fiber, and the 120 TPI casing has only 210 denier, for example. It's a term what defines the thickness of the fiber. Very lower grade tires using 26 or 30 TPI. We don't use this. We use from 60 TPI and performance tires only, and usually all the tires are made from 60 or 120 TPI of nylon. The 300 and plus TPI, these are usually polycotton tires. where the casing carcass is not nylon, where it is cotton. So this is way thinner material, and for that reason they use more fibers per inch. So a really good sweet spot fiber to work with, which is light, has low rolling resistance, and have a really tough cut resistance as well as 60 TPI. This is really a sweet spot fiber where you can make really good tires from it. Between these and 120 TPI, it is a relatively equal rolling resistance. But 120 TPI has just the advantage that it is a little bit lighter. The weight difference doesn't really come from the nylon fabric itself. It is more that the 120 TPI, since the fiber is thinner, and with a thinner fiber you have smaller gaps in between the fibers, it is thinner filled with rubber when it's impregnated, and then you have just can just make a lighter weight tire with 120 TPI, but in terms of rolling resistance relatively equal. But also the 60 TPI has a better cut resistance because the fiber is thicker and it takes more energy to cut through, basically.
Thank you for that. That makes a lot of sense.
And then you can incorporate in the tire all kinds of different reinforcement materials, kind of a woven grid material, and all kinds of different wavings or additional cut protection layers underneath the tread pattern, which is common in road tires, for example. In mountain bike tires, you focus a lot on sidewall cut resistance. So depending on each application and how you use the tire and what is the terrain, you can then basically incorporate all kinds of different reinforcement materials in the tire. Or in a DH tire and a downhill tire, you also use a kind of an apex, which is also a rubber what reinforces what sits above the bead and stiffens up the sidewall and stabilizes the tire, as well as it helps also with pinch flat protection, for example.
Okay.
Yeah.
Well,
and then of
cool.
course the masterpiece or the master the ingredient or part what you need is really then the compound. No? The compound is really a main driver for the tire performance. So and with its properties, that the compound is really with its properties built and dialed in to the use case, to the application, and really speaks to the frequencies, basically to the road vibrations or the trail vibrations, to a certain frequencies, what happens in the terrain you're riding, that the compound delivers best damping properties and in terms of rolling resistance and grip level to this application where the tire is designed for, where you use it.
So when you are saying compound, you actually mean the mixture of rubber.
Yeah, the tread. Mainly the tread compound. Now, what is basically the compound, the rubber compound, where your tread profile is made from.
Okay, so all the knobs and stuff like that on top of the tire, or on the side of the tire.
There is really a magic in this.
Okay. Can you say something about, like, because now we see, and not going too deep into this, but I know Specialized are using, for example, T5, T7. So there's like different kind of compounds on the top of the tire and on the side of the tire. And just for the back of my mind, I would prefer like having a good grip when I cornering, and I would have like really low rolling resistance when I go straight forward. So are there like, what is the difference between the different compounds? If you can say a bit about that, not a half an hour.
Yeah, as I said before, I use the term frequencies. Your tire compound has to be dialed in to the frequency range where you are riding on. For that reason, you need certain damping properties designed into the tread compound. You cannot suit well with one single compound from road to DH racing. This does not work. A road compound, for example, using a DH casing, it would just bounce around because the rebound is so high that you would just bounce from stone to stone, and the tire would not build up grip when you jump on those stones, for example. The opposite around, if you use a downhill compound on the road, it would just not roll. It would just stick to the ground, and you need to pedal endless of watts to move on. Huh? So it's just because the damping properties that are so high that the tire really sticks to the ground and really smoothens basically really the part where you're rolling over to have also minimum vibrations in the handlebar, for example, because also the tire and a downhill bike, for example, is part of the suspension chain. And in this change, the tire hits first the ground, and you want that this first initial impact also, that there is a lot of initial grip, for example. And for that reason, all this vibration and frequency, what happens there has to be basically cancelled. And this is what the tire compound basically does in this case. And for that reason, you have to rank them in a certain range. And we did it from 1 to 10, for example, and we called it then T. T stands for tread compound. And at the moment, within our compound range, we have 4 different compounds. We have T2, T5, T7, and T9. T2 is our fastest rolling compound for hardpack asphalt conditions. T5 is a very, very good all-round, well-balanced compound. It has very good wet grip on the road and off-road. It has really good vibration damping for gravel and hardpack, and also on kind of smaller routes and grass and stuff. T7 is a trail compound with more damping properties as well, and T9 is a full-on gravity compound, which is just built for grip, for example. And so for on the road, we use only T2 and T5. This is what works there. Mountain bike, also gravel is also T2 and T5. Mountain bike, cross country is then T5, T7. And for trail and downhill application, you will use T7 and T9 compounds. This is how it is ranked. As lower the number, as faster rolling resistance, as higher, as more damping properties you have.
Makes sense. So let's move into to the gravel tires. You brought on I would say a new tire lineup with still the same names. So we have the Pathfinder, we have the Tracer, and we have the Terra. The Terra is a new one, and it covers it takes away the earlier one who's called Rhombus, as far as I believe. But can you? I think we should just go through the 3 tires, if it's okay with you, and maybe start with the Pathfinder. I would say the Pathfinder is a really, really, really popular tire here in Denmark. It's got especially the Pro version, because of like really good rolling abilities, but also quite good grip cornering. So I would say it's and then it's really trustable, I would say. So people are not flatting or puncturing very much on this tire. So it's a really popular tire here. But you made it completely or more or less completely different with the new ones. So we don't see the S-Works version anymore. And the Pro version is not here either. Now it's just the Pathfinder. Can you tell us a bit about like the highlights in this tire and what your ideas behind the tire has been?
Yes, for sure.
Very good.
So we basically renewed our complete tire line. A lot of the tires are really brand new and new designed, although with kind of new tread pattern for sure, kind of some new materials, depending a little bit on the category. What we, of course, also basically did, or what was also a focus of this program revision, was consumer facing with a great purchasing experience, that if I look for a tire for a certain application, that I find it very, or as simple as possible, that I don't find too much variety in a tire where I don't know what variant I should use. Is this the right one for me? So we kept it, I think, very precise to the tread and to the name, so we can position it very sharp. And as a consumer, you see from the positioning statement, okay, this is my tire, or this is even not my tire. I need to look for on the right side or on the left side. And we avoided to create too much versions where small, with just small differences sometimes, to not irritate the consumer. Yeah. Also, a nice anecdote here is that most or a lot of consumers who are not satisfied with their tires, it is oftenly not the tire itself, it was just the wrong tire choice, a wrong purchase, because the description probably was not right, or the right tire was not available and I just bought another version of it and it doesn't really suit my use case. So for that, bringing all this into the new tire line, we tried to keep it more simple, eliminated variants where no variants make sense, eliminate, for example, specialized owned terms. For example, tubeless ready was also, the shortcut was 2BR. Nobody really knew what it is, especially not new rider. We have also a lot of new riders coming into the sport, especially on gravel. Nobody knows it. So we said, okay, we use the industry common term like TLR for tubeless ready, what is also part of the norm, and everybody understands this, keeping things easier. And then of our learning also told us from the past, that you, of course, you start a new thing and then you see demand and you do some variety, and at some point you need to bring it together because you figure out market demand as well as how the riding may be developed and the experience got made, that you can live with one single version, and if it's developed properly, it works fine. And this is how we did it with the gravel line. So you really have at the moment Pathfinder, Tracer, Terra, TLR, and this is all what you get. You get 3 treads, and all these tires are developed for the use case, how we have them designed for Pathfinder as a fast gravel tire, Tracer as an all-terrain gravel tire, and Terra as trail orientated or for rough bike packing terrain, for example. And within this positioning, the tire is made for speed like you want it, the grip level like you want it, protection level like you need it. So there is nothing missing, and we just eliminated the variance, and we designed the tires basically to the positioning where they are made for. How we came to this, we had more gravel tires in the past. Of course, it was growing, and we had Trigger, Tracer, and Terra in the beginning, which were cyclocross tires, and then some of those tires already transitioned with wider sizes into gravel. Then we had a Sawtooth tire, for example. Then we made the Pathfinder tire. Then there came up the Creo bike, so the electric power gravel bike. So we made the Rhombus because we thought, okay, maybe people ride steeper terrain with it or harder terrain with it, but it doesn't work out like this. So with the new line, we were analyzing, okay, what are the best and strongest name, and also what fits from their naming perspective, from the nomenclature into our new line. And we came up with that we consolidate the line, all the threads what we have, into Pathfinder, Tracer, and Terra. Pathfinder because it became very popular, and also the thread was very much appreciated, how we have designed the original one with the slick center and the fragmented smaller transition and shoulder knobs. Tracer was always kind of an all-terrain cyclocross and gravel tire, and Terra was in the past the mud tire, so for rough terrain. So we used this tire for the trail tire now, and so we came to these and have built the whole new gravel line around these three threads for the moment.
So no more like different levels of tires within the exact tire. Now there's only like one version, but in different width.
Correct. Yes.
Okay.
Yes.
What did you do, especially with the Pathfinder tire, to optimize that? Because earlier you had the S-Works version, who was a really fast one, but with, I would say, less traction, cornering, and so on, compared to the Pro version. So as far as I can feel when I'm riding the tire, it feels, I would actually say faster than the S-Works tire. It's like, first time I was riding the tire, I was like, I was amazed because it just felt super fast, like super fast. And I was just riding out of Velofit at the pavement or the asphalt, and it just felt like really, really low rolling resistance. And then I was a bit curious, hitting the gravel, and I did that, and just first corner I felt, okay, I can actually push this tire, also cornering. So the grip was doing really, really well, and I would say definitely as good as the Pro version. And there next, I was of course a bit afraid. You have a really fast tire, there's good cornering abilities. What about flat protection? And as I said at a podcast yesterday, I had two flats on one in the front, one in the rear, and it was mainly my own fault because I was running like too high tire pressure going to work, and I hit some glass and I caught the tire. And the other one was like a really, really sharp stone at the rear tire, also just bad luck. But the ceiling was like fixing it, and I could ride on it. But did you take some qualities from the earlier version and mix it together, or did you just like skip everything and build up a new tire?
No, of course we kept the good experiences and tried to improve the bad ones and also improve the good ones. We started with the Pro, or the Pathfinder Pro was the very first dedicated gravel tire with this unique design, with the slick center and then the fragmented tread. That's true. Where the tread is kind of relatively high and very durable. Also makes the tire a little bit heavy. The original tire was also made from 120 TPI casing, so the thinner one, the lighter one, also with lower protection level. The S-Works, when we did it, we made a much shallower tread. So we trimmed the tread very much down to reduce the weight and reduce rolling resistance and make the tire a more sportive feel. This was very much appreciated, but the casing was also very light and not so much protection built in. It was sufficient, but not basically. It was sufficient for the how the tire was made. For lighter gravel, it worked fine. Nobody had really problems with. No problem. But for rougher terrain, maybe it would be a little bit too weak though. Also, we had a lot of feedback from racing. And all the gravel races, usually self-supported races. Flatting is the biggest problem, biggest time loser. No? So no problem. So also our racers, they also we need also durable tires. And also we did then some more reinforced Pathfinders for them in the past to try out that. When we moved into the new generation of the Pathfinder, we had ideas in mind in terms how the bike should handle, what we can influence with the tread pattern for sure. We had rolling resistance goals, weight goals, as well as protection goals. And what we basically did is, starting from the tread, for example, we redesigned the tread. We reduced a lot of rubber from it and were orientated on the S-Works tread, more or less, in terms of the thickness and the weight of the tread. But as well, we want to keep the grip level of the Pathfinder. So what we did is basically we have the center a little bit thicker than the S-Works, but much thinner than the Pro. And then the knobs are also more spaced out and also larger, so they can carry more load, but they can also grab more into the ground. So also when you then also the tread, when it's flat on the ground, it's more equally loaded. The knobs are more equally loaded and grabbing into the ground when you sit on the bike. Where at the Pathfinder Pro and the previous version, a lot of load was in the center. This is now much better. This makes the tire much better handling as well as more traction and on going off-road. Another thing what we did is we use now 60 TPI casing. So we made the tread thinner but increase cut resistance on the casing in the tread center as well as on the sidewalls. We reduced more weight from the tread than the thicker casing would add. So the new tires are lighter than the old tires. When you basically compare a 42 Pathfinder Pro old one with a 45 Pathfinder TLR new one, the TLR is around 20 to 30 gram lighter, even with more protected casing. To make them even faster, then we also changed our compounds. As I described before, we have different types of compound, and the Pathfinder get ridden a lot on hardpack. So we use our road racing compound in the slick center, the T2, and before it was the T5 in the center and the T5 on the shoulder. So the new Pathfinder TLR is a dual compound with two T2 in the center and T5 on the shoulder. That helps the tire a lot with way better rolling resistance. And there's also for the terrain, you ride the tire, no issues or too much trade-offs in grip when you go off-road. The rolling resistance dominates the performance, as well as the new grip with the new knob configuration helps also a lot building up the grip. So there are a lot of things what we have combined from Pro and S-Works, as well as also brought in 60 TPI instead of 120 for the cut resistance. Of course, the tires are not completely. It's also a very fast and rolling performance optimized tire, and not full on flat proof with super tough materials in it, what would make the tire harsh riding, heavy and slow. Like a sharp piece of glass, for example, can always happen and can cut through. Unfortunately, yes. Or even tire pressure, wrong tire pressure is also kind of can happen, can causing flats easier, as well as maybe very sharp rim hooks. When you have a rim with a very sharp hook, those are also bad for pinch flat protection if the rim is very sharp. So it's kind of combinations that suit well together is also very important.
That makes a lot of sense. And this tire is coming in 35 millimeters, 40 and 45.
Yes, correct.
Yes. The Tracer one is is a bit in between, so it's more all-terrain orientated. You also see that on the thread pattern. There's more there's more grip in the center of the tire. I believe that the Tracer, the old version, was 60 TPI, and it still are, I believe. But what did you do regarding the compound placement and any new things about the Tracer compared to the old version? I would say it's available in 50 millimeters, and it fits the crooks really well. Matthias from Velofit is running it and very happy about it. Also because he's going to do the Trackhead 360 on it, and I will probably run it at the Rift later this year. But can you say something about the Tracer tire? What is new to that compared to the old one?
Yes, previous generation Tracer was made from 60 DPI. That's correct. It's also where we had also experience with that it works great, and we use it now for the Pathfinder. So Pathfinder, Tracer, and Terra, the new tires, they all share the same casing. They vary in the tread, which is obvious. Now they have a different tread design. Where Pathfinder has a dual compound with T2 and T5, and Tracer and Terra has full T5 compounds. Comparing new Tracer to the old Tracer, what we can say have improved the most is a bit higher grip level. The old Tracer and Pathfinder Pro were very close together in use case and in ride behavior. So we set these apart. As I said, Pathfinder became more hardback and faster orientated, and now the Tracer became, compared to his previous version, more cornering grip. So we enlarged the shoulder knobs and make them also higher, but also at the center tread is also a little bit higher knobs than in the past. So
and more spread out.
Yes, is kind of built more to a little bit more traction than the old version of the Tracer. And the Terra, Rhombus was too aggressive, was too much, and Terra is just a little bit lighter build here in terms of the tread, so it's a little bit more sportive riding than before.
So, but still with a bigger thread than, or more robust thread than the Terra ones.
Yes, correct. And you also mentioned it. We have new sizing. The Pathfinder is 35, 40, and 45. Tracer is 40, 45, and 50. And Terra is only in 45 and 50 available.
Okay. So I have a question for you. What is the fastest width?
This depends also. That's a very good question. And it's also very hard to answer, where we also still look for the right answer, to be honest. It depends a little bit, or it depends a lot on the terrain as well where you're riding. If you're measuring rolling resistance on a drum from narrow to larger tires, if you would inflate them all the same, I guess you know it, then the bigger tire has always the best rolling resistance. Not they're all same inflated. That's not how you're riding. If you would set up riding pressure on all these tires and you do rolling resistance test on a laboratory drum, the rolling resistance is the same for all tires, for all sizes. It's basically equal on a smooth surface. But when you ride gravel, for example, it's not really smooth. You have a lot of obstacles where you ride over and so on. So if you think about this, and then your wider tire is not just wider, it has also a larger diameter. So and a larger diameter can easier roll over obstacles, even if it is lower inflated, for example. So if you ride on the road, on pavement, it is pretty much equal if you have narrower or wider tire. If you go over obstacles, the wider tire with the larger diameter as well could have some advantages in this. It's also important, how to dial in the tire pressure, that this is right and so on. But it rolls easier over obstacles. You can also run kind of lower pressures here because you can store more bottom out energy. So it means your pinch flat risk is lower. And then your tire can basically adapt easier to the ground as well. And for that reason, you're bouncing less around and you're saving energy because all your pedal force going onto the ground and not get lost in the air.
So it sticks to the ground all the time.
It deforms better, the wider one, and also not just that, but also since the diameter is also larger, it rolls better over it. No?
Yeah, so I remember the I can't remember the exact word, but the attack angle of an obstacle when the 26 inches tires was out and the 29 trainer was coming in. There was a lot of talking about the rollover capability.
Yes, correct. It's pretty much the same. What you have here as well, because your larger tire is also higher.
Yeah. So because I've during the winter I've been testing the Renegade, also on the Crux, the 2.2 version, and I had to cut off all the side knobs of the rear tire to actually fit it in. So. There's 160 knobs at each side, I believe. They are all over my floor back home still. But I really felt that the rollover capability, especially in rough terrain, was really a big advantage. But like coming out to the pavement, asphalt, with the low tire pressure, I felt it was like the tire was gluing to the ground. Which also has something to do with the compound, I guess.
But on the old
it's the new Renegade.
It was the same. So
it works.
Yeah, but it's also all T5 compound.
Okay. It could have been like the tire pressure.
You have also more mass then, also more compound mass than on this tire for sure.
Yeah.
But yes, there's
But still, it was super nice to ride, like super ride
quality
off-road, and
yes.
Like fantastic grip. So, but it feels like there's a lot more speed in the Pathfinder 45 tire, like overall speed, when I like compare to pavement, rough terrain, smooth gravel, and so on.
Yeah, it depends also a lot on the terrain. If you imagine, for example, unbound gravel, 300 kilometers, how many corners you have there? 50 in 300 kilometers, all straight line. Of course, such a wide tire, what deforms, is super nice to ride. most probably. It's different if you have probably a cyclocross, a gravel race in a different course where it's
for example.
we have switchbacks maybe, or single trail, or also a lot of road. If you go very fast on the road, where probably and then also kind of aerodynamic matters a bit more. There's a lot of variables in there, which is course dependent.
Yeah,
what I'm saying. Yeah.
Okay, cool. Just as a thought, when I was reading about the new Pathfinder, for example, and that was the first time I saw that, was that you were literally comparing yourself to competitors for the first time. In from my point of view, you were saying that you were faster than the Conti Terra Speed and the Schwalbe G or something. Like, did you? Of course you did. I hope so. Did you literally tested the Pathfinder and compare it to the speed or whatever to the other tires? Is that correct?
Yeah, I guess every brand does it. No matter on what is working, it is observe your competitors, no? Basically. Same what we are doing. Of course, if there's any kind of new tire coming out from any brand, of course we purchase it. We look through it. What did they change? What makes it different? What is performance numbers in terms of rolling resistance or puncture protection and the weight? And for example, of course, we analyze this whole field, of course, and that's what you claimed here. I think it was not in our official marketing, to be honest, but of course we did it for some sales sheets.
I think it was in the press material.
Yeah, can also be. Maybe they put it in, but we worked it out, of course, also for arguments.
Don't get me wrong. I think it's fantastic because it's also like ammunition on the sales floor, basically. When you just say this tire is faster than the Conti,
and that's what we did. Yes. Because normally was tested in our own lab. Here it was not tested in the outside field or something. It was a laboratory test here on a typical rolling resistance rig on a smooth drum, and
okay. Well, I think it's cool. I like it suits my way really fine to be a bit more aggressive. Normally it's like a comparison to the older version. We are 10% faster or like 30% better cut resistance. Now we know that the Conti is also doing really well out there. I would say we almost through the agenda. I have one question here in the end, and it's maybe more an advice or a rule of thumb. When we were talking like shortly about it, the tire pressure. What would typically happen if you go too high or too low, and there next, what is the right pressure?
Yeah, it's interesting. If you go too high, you go off-road, you bounce around a lot, have no control really. The tire cannot really conform to the ground, and you're just bouncing in the saddle, and your handlebar is vibrating, and it's just not a nice riding feel. If you go too low, it's also you can have pinch splits very quick, as well as when you corner fast, the tire is not stable, and it folds over, and you have no control basically. And what is interesting, I think, is there are some really good pressure calculators out there in the internet from all kinds of brand, where you can type in your terrain, your body weight, system weight, tire quality, rim width, and everything. And it gives out you some really good recommended tire pressures, I think. interesting is if you are a kind of experienced rider or ride on a regular basis and take it a little bit serious, and you dial in your tire pressure by feeling and your terrain you are riding, and then you check it with those calculators, it's plus minus a little bit pretty similar, I guess.
Yeah.
That was my experience across all kind of different disciplines, let's say, from gravel tires, road tires, or cross-country mountain bike tires. No? Doing here my loops here in our area here, and then dialing in tire pressure by feeling, and then double checking with those calculators, and pretty much you're ending up by this. I think when people ride frequently, they find really good and really fast preferred pressure if you put in a little bit of effort and think about it a little bit, yes.
Yeah.
Or use just these calculators, and then you are there.
Well, I have one funny story about that. Back in 2010 or 11, I did a cyclocross race in San Francisco together with the SBCU chief, Andrew Hammond. I think he went to Pelishumi afterwards, but like he was also a cyclocrosser. And before the race, I was just like gripping the tire, like, by feel. And then he was looking at me and he said, "Well, Thomas Bungard, you need to be a bit more scientific about it." And but everything was like tubeless, and there's a lot of latex like getting squeezed into the valve. And then when you're using the manometer or the tire pressure thing, it always get a wrong number. It's not accurate from my point of view. So since then, I always just been using the squeezy method, using my hands, using my feeling. And when the valves are completely new and I set up the tire and I go by feeling, I also like compare it to the numbers from the tire pressure calculator. And I always find myself to go a little bit like less pressure than the recommendation. But again, it's like my background is from mountain biking, so yeah. But I think trusting your grip, meaning that your feeling around the tire, that's always from my point of view a really good way of doing it. I don't know if you agree on that.
I trust myself there,
Yeah.
but I also experienced that I sometimes was wrong.
Okay, yeah. Me too.
Yeah.
One final question, just again a personal experience. Have you noticed that when you are like pumping your tire, for example, before a race, and then you think, okay, this is good, and then within a couple of hours in the race, when it's getting like warmer during the day, the tire starts to feel more inflated, so that the tire pressure actually increased a little bit. So we know from like doing road races like in the Alps, where you like pump the tire at the top of the mountain and you go down, and the tire pressure changes and you blow out the tire on the way down to the start, like a classic La Marmotte mistake. But will the temperature affect the tire pressure, like for example from 10 degrees to 25 degrees during the day if you go gravel?
It's not that much.
Okay.
I think the formula is that 10 degrees changing 1 psi.
That's not much.
This is the formula. That's
Okay.
not much. What is temperature sensitive, of course, and there's also a lot of variety in it, is the compound. The compound behaves differently in different temperature ranges. So that could also make that you're depending a little bit on that. It gets very scientific now, no? On the glass transition temperature of your compound polymers and where this is set. So depending on the temperatures, that then the compound becomes harder or softer, and then it feels basically different.
Okay.
But you can also Google this very easy. It's just physics. That the the temperature in a closed basically tube or whatever, changes 1 psi with 10
degrees.
degree temperature
Okay.
changes. Yes.
That's good. But it's more likely that it's the compound who changes behavior, judging from like 10 degrees to 25 degrees.
Yeah.
Okay, but a higher temperature will make the compound, I would say, more soft. Not necessarily.
As I said, really depending a bit on the recipe.
Okay. Well, Oliver, that was a little bit more than an hour. Do you have more to bring in? Otherwise, I'm really happy about this. I learned a lot. I thought I knew a lot about tires to begin with, but I must admit you filled in some gaps. So very nice.
It's interesting how much you can speak about just bicycle tires, no? And we just hit a little spot in there.
Yeah.
Yeah.
But it makes super much sense. Also, like the T2, the T5, the T7, and T9 compounds. How you mixing up these, and what is the benefits of these different compounds, and how you're using them. It makes a lot of sense all of a sudden.
Yeah, nice.
So, anything else?
I'm fine, thank you.
You good?
Thanks for having me.
Well, thank you so much for bringing in all this knowledge, and also for I'm almost like thanking you for bringing in some new faster tires. I really think we us running them having an advantage over our competitors right now. So that's really nice. So thank you, Oliver, and have a good day.
Yes, thank you. You too.
Ciao.
Bye.